Okay, we're going to start section 5.5. Our first technique of integration, remember integration, anti-differentiation, same thing, is called U substitution, or the substitution rule. Is the most general antiderivative of sine x equal negative cosine x plus c? Take a minute to say true or false, yes or no. Well, let's see. Let's take the derivative of negative cosine x plus c, and we get negative. The derivative of cosine x is negative sine x. Negative negatives are positive. This matches this sign, so the answer is yes. So is the most general antiderivative of sine of 2x, is that equal negative cosine 2x plus c? Check that one. This negative comes out front. The derivative of cosine 2x, that's a composite function. There's an outside and an inside. The derivative of the outside is negative sine. But I got to multiply by the derivative of the inside. Remember chain rule? Negative cosine 2x is a composite function. I have an outside and an inside. Negative negatives are positive. Derivative of 2x is 2. So I get 2 sine 2x. Oh, I'm supposed to get what? Sine 2x. So this one is no, right? The first one is true. The second one is false. Now, what's the difference in this first one and second one? Notice that in the second case, I'm anti-differentiating a composite function. I have an inside and an outside. When you want to anti-differentiate a composite function, unless there's some algebra you can do to get rid of the composite nature of the function, and certainly in this problem there is none of that, then the technique of U substitution or integration by substitution is helpful. And I'm going to illustrate that now in just a moment. But before we do that, is the most general antiderivative of sine 2x equal negative 1/2 cosine 2x plus c? Think about that. Notice when you differentiate the right-hand side, we do get the integrand, don't we? This 1/2 times 2 is just 1. So this one Yes, this is true. And isn't that believable? Because if you look at the second one, we guessed, here's what a lot of students do. They know that antiderivative of sine is negative cosine. They've memorized that because that's in your table in section 5.4 in that table of integrals. You know the derivative of negative cosine is sine, so the integral of sine is negative cosine, or the antiderivative, same thing. So in place of the sine x, what do you have? Sine 2x. Well, they kind of apply this rule, and they get negative cosine 2x. But the rule doesn't work if you've got a function of a function, because when you differentiate this right-hand side, I don't get the left-hand side, I get double the left-hand side, right? I've got double the left-hand side. So to compensate for that, does it make sense that my real antiderivative, my real answer, to compensate for when I guess the answer and it was double what it should be, does it make sense just take that previous guess here and multiply by 1/2 to undo the doubling? That does work, doesn't it? Some students do that instead of use substitution, and that's fine. There are some problems that are complicated enough, though, that you probably will need the technique of use substitution on those. So you should learn the technique of use substitution. On a problem like this, if you want to compensate, guess what you think the answer is, check it. If the answer is double what it should be, just take 1/2. There's not a problem with that. But you do need to also know use substitution. Now, let's find the most general antiderivative of sine 2x using use substitution, or what section 5.5 calls the substitution rule. Now, here's what I need to tell you about this first. This is highly symbolic. It's going to look like we're just pushing symbols, and we really are. It's very procedural. It works, okay? It's a tool we're learning to use and putting in our toolbox. A little bit of it is going to be procedural, just pushing symbols. You're not going to really know exactly why we're doing this. Someone just discovered that this works, okay? Here's the deal. I know I want to let u be the inside function. Generally, if I want to anti-differentiate a composite function, sine 2x, there's an inside and an outside, I'll let u be the inside. Now, the next step is do something called take the differential of u. Now, the differential, this is where it's going to look like symbol pushing, okay? This is a little du. It's not a derivative. We don't write it du dx, okay? It's just little du. What we mean by that symbol is, this is a new symbol. By the way, there's a section back in chapter 4 that we didn't look at that talks about differentials. Okay, it's really not on the syllabus at MTSU in calculus. If we'd had a little more time, we would have spent a little time in there because I think it's helpful. But it's really not on our syllabus. The differential of the dependent variable u is just the derivative times the differential of the independent variable. The differential of u is just the derivative of 2x, which is 2, times dx. Okay, that's a step you just do every time. Okay, again, this is procedural. So how do I take the differential of a dependent variable? I take the derivative, and I multiply it by the differential of the independent variable. Okay? Now, my problem is now antiderivative of sine u, right? Sine 2x is sine u because u is 2x. Now, what's this dx here? Look, here's the dx. That's du over 2, right? If I solve this equation right here, du equal 2dx, dx is du over 2. So I'm going to replace this dx with du over 2. Again, this is highly procedural, but it works. Now, I can factor this 1/2 out front. The idea is I'm taking a function that's a little bit complicated using the variable x, and I'm replacing it with one that's simpler using the variable u. This original problem, antiderivative of sine 2x, and 1/2 antiderivative of sine u have the same value. It's just that this one over here on the right is simpler, because if the variable is u now, if the independent variable is u, what do you differentiate with respect to u to get sine u? What do you differentiate with respect to u to get sine u? Isn't it just negative cosine u plus a constant? In other words, go back up here to the top. Go back to the top. Didn't we say that antiderivative of sine x dx is minus cosine x plus a constant? That's the same thing as saying antiderivative of sine u du is minus cosine u plus a constant. Okay? It doesn't matter what you call these variables. These two things say exactly the same thing. So I've made a substitution, a change of variables, to change something that's a bit complicated looking into something that's less complicated looking, and in fact something that I already know because it's in my table of antiderivatives in section 5.4. Now, 1/2 times a negative is negative 1/2. If your original problem has x in it, you want your answer to have x in it. So go back to where you made your substitution, u is 2x, and make that substitution back. If your original problem has x, you want your answer to have x. If you transform your problem by change of variables into an easier problem to get an answer, then in your answer, undo that transformation and get your original variables back. Now, is this the answer that we checked a minute ago? Didn't we do this problem, didn't we check a minute ago and see that in fact negative 1/2 cosine 2x plus c was our answer? This is extremely important for Calculus 2. They'll assume that you can do u substitution, and we just need to practice on it a whole lot more.